I'm Anil Kumar, and in this video, we'll take a few examples to understand direction and magnitude of vectors. Well, as you know, what are vectors? Vectors are quantities which have both direction and magnitude. That's what we say, right? So let me give you a few examples and then we'll try to understand how to represent these vectors. Let us say we have a force of 10 newtons and it is being applied in the direction of east. Let's say this be one vector, right? Let's say we have a velocity of let's say 80 kilo. I wrote 8, that's okay. So 8 kilometers per hour, and let us say the direction is from north 40 degrees east. Okay. Let us say, let me write, let's say another velocity which could be, let's say, 120 kilometers per hour, and let us say the direction is 120 degrees, and that is the bearing angle. Let me take more examples. So this is how we are describing vectors. We could describe vector as a position, let's say 3, 4. Okay. At times you will also see vectors written as okay, so let's call this vector as vector A, and let me call vector B as equals to let's say 2I minus 5j. Okay, so I just taken vectors in R2. I could have taken in R3 also. Let's begin with these vectors and try to understand how to find their direction and magnitude. That's the whole thing, right? So that is what we'll discuss now. Let me start one by one. From the very first one, it says a force of 10 newtons. So the magnitude is 10 newtons and direction is east. So whenever we are working, regarding vectors, you could think about XY plane. I took examples based on R2, so this will work for all of them. So when I say 10 newtons east, I could say, well, from here to here, let this be 10 newtons, the length be 10 newtons, and this direction is east. That is the north for us, right? So 10 newtons east, that force could be represented by a vector whose head is at the origin, tail is towards the east direction. So that becomes the 10 newtons east, right? Now, this vector could be placed anywhere. So even if I draw it here, where the magnitude represented by the length, and let's say this 1 centimeter is 10 newtons, right? So we are saying 1 centimeter equals to 10 newtons, and if this length is 1 centimeters, then that gives you the magnitude, and the direction is east, which we have shown here. So that is how you could represent this force of 10 newtons. Okay. Now let's look into the other vector, which is a velocity vector saying 8 kilometers per hour, direction is north 40 degrees east. So 8 is the magnitude. So my length is going to be, let us say, we are saying 1 centimeter is 10 kilometers, right? Let's say per hour. So 8 will be less than a centimeter. But the angle here is from north 40 degrees east. What does that mean? It really means that is the north. So from north, I can take an angle which is 40 degrees. So it is in this direction. Do you see that? So this direction where that angle is 40 degrees. So this direction gives you the direction of this. So this direction is shown by this yellow line here. Now on this direction, I can mark this 8 as less than 1 centimeter, and say this much is my vector velocity, right? So that becomes the velocity. So let's say the first one was F, the force, and the second one was V1, velocity 1. Let me write V1 here. Okay. Next is 120 kilometers per hour at a bearing of 120 degrees. Now what is the bearing angle? Bearing angles are from north. Bearing angles are from north always, and they are clockwise, and they are clockwise in this direction. So we have to do 120 degrees clockwise. So let me just use another ring. This is 90, so 120 degrees will be 90 plus 30. So that direction here gives you 120 degrees. Okay, so this is 120 degrees. Do you see that? And magnitude of 120, so it's pretty long. So let's say this much. Okay, let's say that represents 120. So let me write down 120 here. So that is my velocity 2. Okay, velocity 2, 120 kilometers per hour. From north it is 120 degrees. That's the bearing angle. You get an idea, right? So like this, I can show all these angles which we have worked on along with their magnitude. You see? So magnitudes and directions are given here. Now we'll concentrate on these two. So I'll not mess this up further. I'll make something new here. So we'll talk about the vector A, which is represented by 3, 4, right? What does it mean? It really means that we are trying to represent the vector. If I have this coordinate plane, let me do it here. Then 3 is the movement along the x-axis, 1, 2, 3. 4 along the y, 1, 2, 3, 4. And if I join this, then I could call this as my vector A. And whenever I start from the origin, this will be the position vector. So vectors are free to move around. I could represent this vector anywhere, also here. But if I fix this part here, the tail at the origin, is called the position vector. So this is the position vector. Okay, let's find its magnitude and direction. That's important, right? So what is the magnitude of this vector? We represent this by the bars. Magnitude is a square plus b, these squares. It's like a Pythagorean theorem, right? So 3 and 4 really means we move 3 units towards x, 4 units like this. And that hypotenuse of a right triangle is represented by the magnitude. So I could write this as 3 square plus 4 square. Do you get it? And that is the magnitude. So which will be 9 plus 16 square root, which is square root of 25, which is 5. So the magnitude is 5. Now, how do we find the direction? Well, to find the direction, let's say the angle here is theta. Then what is tan theta? So we say tan theta is equals to opposite over adjacent, 4 over 3, right? So we can find theta as equals to tan inverse of 4 over 3. So now we can use the calculator and find the angle. So we have tan inverse, we shift tan inverse, 4 divided by 3 bracket close equals to 53.1 degrees. Do you get it? So now we can say that the vector A has magnitude of 5 and direction. Now direction could be pointed, you could say from east 53.1 degrees north, right? So you could write east 53.1 degrees north. So I could do like this, right? So earlier we were saying from north. This is a better way of writing, but this is a convenient way of writing. Not wrong, right? But not good, okay. But you could write like this, fine. But I hope you understood the concept, how we could represent this vector in a Cartesian plane, as you can see, and write its magnitude and direction also, right? So let me take the last example, which is B, which is 2i minus 5j, right? So 2i minus 5j is actually similar to what we did just now. Let me sketch it here. So what we have here is along the x-axis, we say that's the direction. I is the unit vector along x-axis, right? So this is I, 1 unit. 2i you reach here. Minus 5j means along the y-axis minus 5 units. 1, 2, 3, 4, 5. So that becomes your vector. So 2i, 5j, so position vector will be starting from the origin, this vector, tail at the origin, head at this point, right? So this point here is basically 2 minus 5. Do you see that? So that becomes your vector. Now in this particular vector, you may find this angle and then write it in any form. And magnitude is how much? We'll follow this method. So magnitude of B is equals to square root of 2 square plus minus 5 square root. So let's use the calculator, which says square root of, which is 4 plus 25, which is 29. That's okay. So we'll just write 29 square root. That's fine. So it is square root of 29. Magnitude is always positive. Remember that. As far as direction is concerned, so we'll say theta is equals to tan inverse. We are saying this is theta for us. From here, opposite side is 5 and this is 2. There's no need to write minus 5. We know this angle, right? So we will find just the angle. It is 5 over 2. We can again use the calculator to find this angle. So it is shift tan inverse 5 divided by 2 within brackets equals to, we are actually writing the acute angle, right? So I should say theta, right? Which is 68.2, let's say, right? 0.198, I'm rounding to 2 degrees. So this angle is 68.2. Let me write this angle as a bearing angle, right? So I will describe this in this form. So what is the bearing angle? Can you tell me? So the bearing angle is 90 plus 68.2. Is it okay? Is it okay? So that is how much it is. So 68.2 plus 90 will give me 158.2. 158.2. So I'm writing as a bearing angle. So I can write the vector B as magnitude of square root of 29. You could write decimal value, and bearing angle, bearing of how much? 158.2 degrees. Do you see that? So that is how you could actually write direction and magnitude of your vectors. I've purposely taken example in R2, 2 dimensions. You could always extend it to R3. I'm Anil Kumar. If you like, you can put a like. Feel free to post questions. Thank you for such a beautiful opportunity to make me explain this point. Thank you and all the best.